So question 9, we'll do A and B sort of separately. So 9a then. We've been given that log base 3 of c equals m and log base 27 of d equals n. Okay, so we need to remember our definition of a logarithm. So this is the equivalent to saying 3 to the power of m equals c, and this is equivalent to saying 27 to the power of n equals d. So that's done through the definition of what a logarithm actually is. It's the power that you put on 27 to get n. It's the power that you put on 3, the power you put on 3 to get c. So we've got our two equations here, and that's your first mark. Okay, we then are going to put it into this format. So the format we've been asked to do is root c over d squared. So root c is 3 to the m raised to the power of a half. And d squared is 27n squared. Now, the biggest problem we have is we want this in the form 3 to the power of y. So whilst the top is okay because it's got a base number of 3, the bottom is not. It's 27. And it's looking for these sorts of patterns in all the log questions, really, because 27 can be written as a power of 3. It's 3 cubed. So we're going to use that fact to write the denominator of this, this fraction as 3 cubed. So then they're both with the same base. So I've got 3 to the m to the half over, now I'm going to replace my 27 with 3 cubed. That's put to the power of n, which is then squared. Okay, so we know that from our index rules from GCSE that if you've got an index raised to another index, you just multiply the indices together. So I've got 3m over 2 divided by 3. Now I've got 3 times n times 2, so it's 6n. Okay. Now, the other rule from GCSE that we need to remember for this is when we have our indices, two indices taken away from each other, so a to the m minus a to the n, equals a to the m over n. Okay, looks like that's a power. Let's just bring that down there. So we're in this sort of situation where we've got our two powers so divided by each other. So we can rewrite this as 3 to the m over 2 minus 6n. And that is our single power, 3 to the power, which is going to give us our final solution and our final answer to this question. So we're having to apply our index rules quite carefully to actually solve this problem. Okay, but then that's one solution, one correct way of getting our final answer. If you wanted to at this point, you could then say, well, that means that y must equal m over 2 minus 6n, but you don't need to do that. You've already got all your marks. Okay, we'll just remove part A and then have a look at part B. So 9b then, we have been given this rather long log equation and we've been asked to show that it only has one solution. So we're probably in the realms of a quadratic here. Now, how are we going to sort of go about this? Well, we need to apply our log rules that we've learned to this question. So I'll write it out in full. And while we're doing that, we can be thinking about what are our 3 or in fact 4 main log rules that we're going to be applying in this question. So the first log rule that we're going to be applying is that log to the base a of something plus log to the base a, same base of something else, is the same thing as log to the base a of those two things multiplied together. Okay, so what that allows me to do to this left hand side is write it as log to the base 4 of the first bracket multiplied by the second bracket. and that's still equal to 1 plus log to 4 14x plus 5. Okay. Now, the second rule that I'm going to be using is possibly what you would have called the fourth law, where we can say that log to the base a of a equals 1. Okay. So in this case, I'm going to rewrite my 1 as log to the base 4 of 4. And what that allows me to do is to write the right-hand side of this equation as a single logarithm as well. Because once we have a single logarithm on the left and a single logarithm on the right, we can effectively ignore the logarithms. Okay, so we're going to apply that same rule that we did on the left-hand side to the right-hand side. So we're going to have log 4 of 4 times by 14x plus 5. So I'm multiplying the two things together, and that is still equal to this left-hand side. So we've now got our situation where we've got our log of all of this is equal to log of all of this. So we've got a logarithm equals another logarithm. So we can deduce from that that 2x plus 3, 2x plus 15 must be equal to 4 14x plus 5. Okay, now mathematically what we've done, we haven't divided by log 4 because that doesn't actually work. We've raised stuff to the power. But realistically, what we're looking to do is just get two single logarithms and we can ignore the logs. So then if we start expanding these brackets that we've got, so we've got 4x squared plus 30x plus 6x plus 45. And that's equal to 4 times 14, so 28, double 28 is 56x plus 20. So we've got a quadratic here. It's not a nice quadratic as yet, but we're going to have a quadratic. And how do we solve quadratics? We put them equal to 0. So we'll rearrange and just tidy up this left-hand side to start with, and then we'll work on getting it all onto the left-hand side to equal 0. So rearranging this one then, we've got 4x squared. I've got 36x, well, I'm subtracting 56x from it, so I'm going to get minus 20x. And plus 45, subtract 20 from that, plus 25 equals 0. Now, I know I need to factorise this, and the question says that I've got a repeating root, which tells me a little bit about how I'm actually going to go about this factorisation. So I know that the root is going to repeat. So that tells me that I'm going to have 2x and 2x there. Okay, if I didn't know that, I'd have to consider the fact that it could be 4x and x, but I'm showing that there's a repeating root, so I don't want to worry about that. Then I'm just thinking, what two numbers make 25? Well, there's 25 and 1, or there's 5 and 5. And again, we're trying to show that it's a repeating root, so it's giving me a really good indication that I'm going to need a 5 and a 5 in here, and that does work because 2x times 5 and 2x times 5 is going to give me my 20x if both of them are negative. Then I've got minus 25, minus 5 times minus 5, which is plus 25. So my solutions here are, remember that equals 0, so it's when 2x minus 5 equals 0. So if I just quickly rearrange this, 2x equals 5, so x is equal to positive 5 over 2 there. So we can say that we've got a repeating root, a repeated root. So one solution, which is where x is equal to 5 over 2. Okay, and that's your final solution to that problem.